Guys, hello. Welcome. Let me know, guys, can you see this? Checking, guys, everything's working. Are we live? I think we're live. Let's have a look. Yes, I think we're live. Guys, let me know, can you hear me? Hello, Poppy, welcome. Hello, CS, welcome, my friend. Thank you, CS, for liking. Guys, in this session here, so those of you that are in my YouTube community, I'm doing some AS revision today. Oh, thank you for letting me know, Poppy. Hello, hope you're well. Guys, how do I get rid of this on the screen? Let's just get rid of that so there's no distraction. Guys, can you see it? Is it everything nice and clear? Thank you, Poppy, for liking. Thank you, CS, for joining here. Thank you for liking as well, CS. So, in this session, guys, we're going to be recapping some topics on the AS.Pure.Maths course. So looking at some differentiation and some integration in today's session. So anyone that is doing A-level maths, okay, this is going to be applicable for you. Okay, sorry that I can't change the settings. I know it's a GCSE maths revision, but this is an AS.Pure live stream. Okay, so anyone on my YouTube, please tell them that I'm going to be on live on TikTok. Okay, on my community post. We'll give it roughly 5 minutes and then we'll make a start. But guys, let me know, how is everyone doing, guys? Hello, Wayne, welcome, my friend. Hello. Guys, anyone coming from the YouTube, guys, please tell them the live tonight's going to be on TikTok. Okay, it will be uploaded, hopefully, fingers crossed, straight after lesson tonight. Okay, so it's currently 7:15. I'm going to aim to finish around about 9 o'clock or just after 9. Or it might go a bit longer. Okay, we'll see how it goes. But in this session, guys, we are going to be recapping derivatives, so differentiation and also integration in today's session. Okay. So guys, anyone from the YouTube, guys, please come over. Hello D, welcome, my friend. Okay, please tell them hello, Sunshine Official, welcome. Hello. Hope you're well, my friend. Hope you're well. Guys, thank you for joining me on this glorious evening, guys. It's quite a sunny evening where I am in the UK. It's pretty warm as well. In fact, I've got no idea why I'm not wearing a hoodie today because I'm actually quite warm. But guys, we'll give it maybe 3 or 4 minutes and we'll make a start. Hello, Phil San, welcome, my friend. Hello. Guys, anyone joining from the YouTube, guys, please tell them that live tonight's going to be on TikTok. Anyone that hasn't got TikTok, this will be uploaded hopefully straight after, if not tomorrow evening, okay, because I've got to obviously give it time to process the download. Okay, hello Richard, welcome, my friend. Okay, and if you can, guys, give us a follow. Okay, I make GCSE content predominantly, but I'm going to be doing a lot more live streams for GCSE and A-level, but tonight's one is going to be on AS Maths. I know the title says GCSE revision, but this is an AS.Pure.Maths live stream. Okay, so I'll give it maybe 2 or 3 more minutes here and then we'll make a start, guys. Hello Marianne, welcome. Or Marianne, sorry. Okay, whilst we're in here, guys, tap the screen, guys, and share the live out if you can, and also repost if you can. Thank you, CS, for the repost. Okay. Hello, David. Welcome, my friend. But guys, the target is to try and get to 10k followers on here Hello, C underscore E underscore K underscore N or second. Okay, tap the screen, guys, here and share the live out. And we'll be starting literally 1 or 2 minutes, okay? Hello, Angus, welcome, my friend. Let me check the YouTube poll for a second. Hello, AMK. Welcome, my friend, welcome. Guys, shall we make a start? Hello, Sarah, welcome. Guys, shall we make a start? Okay, I'm gonna start now. Okay, so it's now 21 minutes past. Okay, so the first topic we're gonna recap, okay, or go over differentiation. Hello, Hader, One King, welcome, my friend. Hello, hello. Okay, question number 1. We are told that y is equal to 2x cubed plus 5x squared minus 7x, okay, minus 20, is our function here, minus 7x plus 10, sorry. Part A, find y over dx. So, the key here, that the power goes down as a multiplier and the power reduces by 1. So it's going to go to 6x squared, okay, then 5x squared is going to go to 10x, okay, 5 times 2 is 10, okay, and minus 7x is going to differentiate just to minus 7 or negative 7. Then differentiating a constant obviously goes to 0. So that's part A done. Okay, well done. Yep, well done, Hader King. It's spot on. Okay, part B, guys. Find the gradient of the curve when x is equal to 2. So I'm going to sub in x equals 2 to work out the gradient. Okay, at that point. Remember, by dx, the gradient function at that point. Hello, Lana. Welcome. Okay, so we're going to have 6 lots of 2 squared plus 10 lots of 2. Okay, minus 7. Okay, put this here into the calculator here and let it do its job. When we do that, okay, thank you for the heart me. Thank you for the heart me, Hader. I appreciate that. Okay, thank you for the gift. Okay, so 2 squared is 4, times it by 6 makes it 24, plus 20 makes it 44, minus 7, 44 minus 7 is going to be 37. Okay, so that's part A done. Okay, what about part B? We are told that y is equal to 3x plus 1 over x. Find y by dx. So step 1, write it in index form. So we're going to have y is equal to 3x, okay, that's fine. 1 over x, okay, in power form, in index form, is going to be x to the minus 1. Okay, remember that negative power makes it the reciprocal. Okay, I can now differentiate as normal. dy by dx, 3x goes to 3, and then x to the minus 1 goes to minus 1x or minus x to the minus 2, or I can just rewrite it as 3 subtract 1 over x squared, okay, or 3 minus 1 over x squared. Okay, well done, yep, spot on, my friend, okay. Okay, that is correct. More than Hader. Okay. Part B. Find the x coordinates. Okay, of points. X coordinates of points where the gradient is equal to 0. Okay, so I'm going to set this equal to 0 and then solve it. So we're going to have 3 subtract 1 over x squared. Okay, equal to 0. Now I'm going to solve this, so rearrange this equation. So I'm going to add 1 over x squared to both sides. So I'm going to have 3 is equal to 1 over x squared. Okay, times up by x squared, yeah, and then by 3, yes, simultaneously. We're going to get x squared is equal to a third. Okay, and opposite of squaring, okay, so obviously, yeah, square root. Hello, Abbas. Welcome, my friend. So x is equal to plus or minus 1 over root 3. Okay. Thank you, Sam, for liking. So plus or minus 1 over root 3. If you rationalize that, plus or minus root 3 over 3. Hello, is it possible to go through some differentiation modeling? I can do it at some point. Yeah, I'm focusing just on this topic today. Okay, and integration. I can do that, yes. Okay, at some point. Is this GC? No, it's not. Okay, this is actually AS level. Okay. Question number 3. F of x equals 3x to the power of 3 halves plus 3 over x squared minus 6x. Find f dash of x. So I'm going to differentiate this case. So find the first derivative. Again, step 1, write it in index form. We're going to have 3x to the power of 3 halves. 3 over x squared can be written as 3x to the minus 2. And then don't forget that minus 6x here at the end. Okay. Now work out the first derivative. So differentiate this. Okay. What we're going to get, we're going to have 3 times 3 halves, all equal to 9 halves. So we're going to have 9 halves x to the power of, and then not come from the power, that will go to half. Okay. Then 3x to the minus 2, that will go to minus 6x. Why did I put a 3 there? Minus 6x. Okay, to the minus 3. And then minus 6x differentiates to minus 6. Okay, that's that part there, okay? Question number 4. We've got y equals 4 root x plus 1 over 2x plus 10. Part A. Find dy by dx. So step 1, again, write it in index form, power form. So root x is power of a half. So we're going to have y is equal to 4x to the power of a half. Okay, now 1 over 2x, hello Tate, welcome, hello. Now 1 over 2x can be written as, okay, plus half, I'm going to have x to the minus 1. The reason for that, guys, is because when I because 1 over 2x can be split, okay, as half times 1 over x. 1 over x can be written as x power minus 1. Hence, I get half x to the minus 1. Okay, and don't forget the plus 10. Okay, part E. Find dy by dx. So I'm going to differentiate this. So 4x to the half, that's going to go to 2x to the minus half. Okay, then half x to the minus 1, it's going to go to minus half x to the minus 2. Okay. And then the derivative of 10 is going to be 0. Okay, so whenever we differentiate a constant, it's going to be 0. Okay, does that make sense, guys? Let me know in the chat. Then part B, guys, find d2y by dx squared. So I'm going to differentiate the first derivative again. So 2x to minus half, I'll go to minus x to the minus 3 halves. Then minus a half x to the minus 2. That's going to go to plus x to the minus 3. Okay. So I can just rewrite that, a bit more neater as x to the minus 3 subtract x to the minus 3 halves. Okay. Thank you, Oscar, for liking. Thank you, CS, for liking. Okay, next one. Question number 5. Y is equal to 2x squared minus 5x plus 3 over x. Part A. Find dy by dx. So let's write it here as different fractions. So we're going to have y is equal to, we have 2x squared over x, that's going to become 2x. We're going to have minus 5x over x, that's going to become minus 5. Then we're going to have 3 over x, which I'm going to write it as 3x to the minus 1. I've just split this into individual components. So I've got 2x squared over x, which gives me just 2x. Okay, then I've got minus 5x over x, it goes to minus 5. Then 3 over x, 3x to the minus half. Hello, is it E-I-S, is that right? Or E-S? Okay, so over the x, so 2x is going to go to 2, minus 5 just disappears, you've got 3x to minus 1, so that goes to minus 3x to the minus 2, okay, and again I can write it a bit more neater as 2 minus 3 over x squared. For some reason, I can't actually write there. We got 2 minus 3 over x squared. Okay. There we go. Okay. Part B, find the gradient when x is equal to 3. So what we're going to have 2 subtract 3 over 3 squared. So that's going to be 2 minus 3 ninths, so 2 minus third. So that'll give me 1 and 2 thirds, or 5 thirds. Okay. So again, just obviously put this here into your calculator, okay, and it'll give you 5 thirds. Okay, next one, guys. Okay, so well done if you've been this so far. Okay, let's just delete this so we got a bit more space. Question number 6. We got y is equal to x cubed minus 4x squared minus 3x plus 9. Find dy by dx. So find the first derivative. So x cubed goes to 3x squared. Okay. Then minus 4x squared, when I differentiate, so minus 4 times 2 is 8. So we have minus 8x. Okay. Then minus 3x goes to minus 3. And then the 9 obviously goes to 0. Okay. That's part A done. What about part B, guys? Find the range of values of x for which y is increasing. So it's saying, when is the derivative greater than 0? Okay, so I'm going to be solving this quadratic inequality. 3x squared minus 8x minus 3. Okay, strictly greater than 0. Okay, so when I do this, what do I get? Well, this is going to factorize again. So I'm obviously a bit fast here. And you are on your graphics here. Okay, if you can. Hello, Ryan. Welcome, my friend. Okay, so this is going to factorize into 3x plus 1 times x minus 3. Again, sorry that I'm missing like some steps here, but again, obviously check here if you're unsure how to factorize here a non-monic quadratic from GCSE Maths. Okay, so that's going to factorize. So my two solutions are going to be when x is minus a third and when x is 3. So let's do a rough sketch of this derivative curve. Okay, this is going to be minus a third and 3, like that. Got minus a third there. We got 3. So when is it above the x-axis? Well, it's above it here. It's above it here. Okay, so when x is strictly less than minus a third, or when x is greater than 3. Okay, you can say and actually when it's greater than 3. Okay, question number 7, guys. Okay, might not do every single question because it might take us quite a while. I might skip to some harder ones in a minute. Okay. Right, this next one. Curve has equation. Okay, y is equal to 2x cubed plus 9x squared minus 24x plus 13. Find the coordinates of the curve's local maximum. Okay, again, I'm going to differentiate this. So dy by dx. Okay, now to work out the local maximum, that's when I've got to work out the first derivative. Okay, set it equal to 0. Work out the second derivative, and then sub in the coordinates for the stationary point. Okay, so that's going to go to 6x squared plus 18x minus 24. Okay, I'm going to set this quadratic equal to 0, and then obviously solve. Okay, and work out the solutions. Okay, I'm going to obviously factor out a 6. Okay, because they're all divisible by 6. So we're going to have 6 brackets x squared plus 3x minus 4. Okay, it's equal to 0, guys. So it's equal to 0. Okay, this is a lot more easier to actually factorize. So let's just do it on this page here. So we're going to have 6 brackets x plus 4 times x plus 3. Sorry, x minus 1, I mean. Okay. That's going to be equal to 0. Okay, so our solution, guys, is going to be when x is equal to minus 4, or when x is equal to 1. Okay, so they are the x points. Okay, so x turning points. Okay, of this cubic graph, cubic polynomial. Okay, I'm now going to work out the second derivative. Okay, so I'm going to find the derivative of the derivative, if that makes sense. So work out the derivative of the first derivative. So what's that going to go to? 6x squared is going to go to 12x. Okay. And then 18x is going to go to 18. Okay, so this is what I call the second to the 2y dx squared. Okay, so I'm now going to substitute. Now to work out local maximum, we want it so 2y by dx squared is going to be less than 0. Okay, obviously bigger than 0, then it's a minimum point. So we are going to sub in, yeah, minus 4. Because if I sub in x equals 1, the value of this here is going to be bigger than 0, which is not what we want. So we're going to sub in minus 4. 12 times minus 4 is minus 48. Plus 18, I get minus 30. Okay, which is less than 0. Okay, therefore, the local maximum, or local maxima, you could say. Okay, and lastly now, I'm going to sub in x equals minus 4 to work out my y value, or the y coordinate. Okay, so let's just do it, yeah, my calculator for the sake of ease. So we're going to have, let's just change it into scientific. There we go. Okay, so we're going to have 2 times minus 4 cubed. Let's put that in the brackets. Plus 9 times in a bracket. That's going to be what? 4 squared is that? That's going to be 16. Close the brackets. Minus 24. Brackets. Minus 2. Sorry, minus 4. Close the brackets. And then plus 13. We get 125. So the coordinates of the curve's local maximum, local maxima, is negative 4, minus 4, and 125. Okay, so that's question 1 to 7, guys. Okay, so if anyone wants to actually screenshot this, okay, it is going to, yeah, obviously be posted to YouTube later. Okay, either tonight or tomorrow. Okay. Okay, so we're going to carry on. Yes, we're going to carry on. Okay, what I might do is I might start skipping a few. So I think question 8 should be happy with that. Okay, so yeah, so write it in power form. Okay, yeah, let's actually do 8. Yeah, so we'll do 8. We might obviously miss out 9 here. We'll obviously start looking at question 10. Okay, because that's like an exam style question. So step 1, write it in power form. Okay, so that's going to be 4x squared plus 16x to the minus 1. Okay. Okay. Hello, Zara, welcome. Plus, yeah, 16x to the minus 1, and then plus that one at the end. Okay. So, what we're going to get, guys, well, by dx, so 4x squared is going to go to 8x. Okay. So we're going to have 8x, then 16x to the minus 1 will go to minus 16x to the minus 2. Minus 16, yeah, over x squared. Okay, and the plus 1 obviously goes to 0. Okay, so that is our answer for part A. Okay. Part B, guys. So find the exact range of values of which the values of x for which the curve is increasing. So again, it's when the first derivative is greater than 0. So we're going to have 8x. Okay, and then I'm going to rewrite it here. I might write it as minus 16 over x squared greater than 0. Okay. Okay. What can we do here? Okay, so let's just have a little think. So times up by x squared might reverse the inequality. Okay, so we're going to have 8x cubed, okay, subtract 16, okay, and this is where I'm going to obviously flip the sign. Okay, so I got 8x minus 16 over x squared. Okay, so that's going to be greater than 0. Okay, so we don't actually flip the sign actually because we got a 0. Okay, there. Okay, and then obviously 16, yeah, and then obviously divide by 8. So we're going to have x cubed. Okay, is bigger than 2. Okay, so x is going to be strictly bigger than to the power of a third or the cube root of 2. Okay, so to the power of a third. So that's the exact value. Okay, so when x is strictly greater than, okay, yeah, that, okay, then we get that as our answer. Okay, does that make sense, guys? Are we happy with that? Hello, Leah. Welcome, my friend. Oops. Okay. Right. Okay, so far so good. Right. Question number 9, actually, I think we are going to actually skip on it because I'm pretty happy with that. Okay. We're going to have a go at question 10. Okay. I can do 9, guys, yeah, but it's just because, yeah, obviously it's quite a long document and I'm conscious, obviously, of time. So, yeah, for 9, work out the local minimum. Okay. Differentiate the first, okay, so find the first screen next year, first derivative, set it equal to 0, and then solve the quadratic, find the second derivative, and then sub in the coordinates for which d2y by dx squared is bigger than 0, okay, for a local minimum. For a maximum, yeah, so it's going to be less than 0, and if it's equal to 0, it's what we call a point of inflection. Okay, number 10. Okay, a curve has the equation y is equal to 3x squared minus 5x plus 7. Okay, find the equation of the tangent to the curve at the point 2,9. So I'm going to find the r by dx, so find the first derivative. So dy by dx, so 3x squared is going to go to 6x. Okay, and then minus 5x is going to go to minus 5, and then minus 7, yeah, obviously differentiates here to 0, okay, right, next part, okay, so I want to work out the equation of the tangent at that point, so I'm going to substitute in x equals 2 into here, okay, to work out the value for m, okay, which is our gradient, yeah, at that given point. We're going to have 6 times 2 is 12, minus 5 makes 7, so we're going to have m is equal to 7, we're going to use y minus y1 is equal to m brackets x minus x1. So we're going to have y minus y1, that's going to be equal to 9, is equal to m, which is 7, brackets x minus x1. Okay, so x minus x1, yeah, so that's going to be 2. Okay, I'm going to expand this bracket, so we're going to have y minus 9 is equal to 7x minus 14. Okay, I'm going to add the 9 to both sides, so we get y is equal to, now minus 14 plus 9 to minus 5. Okay, so that's going to be y is equal to 7x minus 5. Okay, so that's question 10 done. Okay, is that right? Yeah, let's just double check. Yes. Yeah, that is right, yep. Okay, brilliant. So that's in the form y equals mx plus c. Again, watch out in the exam. It might be in the form ax plus by equals c. Okay, so yeah, make sure you obviously read the question carefully and obviously refer back to it if you're unsure. Okay, so this is question 10 complete. Okay, question number 11, guys. Okay, this one, yeah, it's a bit more tricky, I think. Okay, so let's give it a go. Okay, so yeah, the answer to 10 is equal to y equals 7x minus 5. Right, question number 11, okay, so it looks a bit more actually challenging. We've got a 7 marker, so it's quite a chunky mark. A set of marks. A curve has the equation y is equal to g of x. Given that g of x is a cubic expression, in which the coefficient of x cubed is equal to the coefficient of x, okay, the curve passes through the origin, and the curve has a stationary point 2 minus 10. Okay, so we're gonna have y is equal to ax cubed plus bx squared plus cx, where a is equal to c. Okay, yeah, because obviously from obviously the first line. So now there's no plus d here because it passes through the origin. Okay, so that means obviously the plus d here is not actually relevant. Okay, because it passes through the origin. Okay, so what do I do now? Well, the curve has a stationary point, so if I differentiate this, okay, I'm gonna have dy by dx. What we're gonna get? We're gonna get 3ax squared for some reason I can't actually write there. So I'm gonna have 3ax squared, and then bx squared is going to differentiate to just 2bx, and then cx is going to go to just c. So obviously remembering, a and c, it's going to be like the same number. Okay, so a will have to be like a third of c. Okay, if it's got a stationary point at x equals 2, okay, then one of our factors of this quadratic is going to have to be x minus 2. Okay, for that. Okay, okay. What next, guys? Okay, so let's just have a bit of a think. Okay, so let's call this px plus q. Okay. We're obviously going to try and obviously compare coefficients. Okay, so we're going to call C A because obviously the coefficient of x x cubed is equal to x. So we're going to change this to a. So we're going to change this to a. Okay. So stationary point when x equals 2. So I'm going to form a pair of what we call simultaneous equations. Okay, because I've got an a and a b. So when x is equal to 2, I have this is going to be 4 times it by 3a. That's going to be 12a. I'm going to have plus 4bx, or 4b, sorry, plus a. So that's going to be equal to 0. Now 13a. Actually, right there. Okay, so I'm going to have 13a plus 4b is equal to 0. And I need to form one more equation. Okay, so I can obviously solve it that simultaneously. So back in the first equation, we got minus 10 is equal, when y is minus 10, x will give you minus 2. When x is 2, y is going to be minus 10. Sorry about that, guys. Okay, so hello, Gaming Harry. Welcome, my friend. Hello. Oh, yeah, Toby asked me a question. Sorry, Toby. Are you still here, Toby? So this is applicable for all examples. For AS.Pure.Maths. Okay. So now minus 10 equal to 8 times 2 cubed. So that's going to be 8a. So b times x squared. So that's going to be 4b. We're going to have 2a. Oh, I remember you, Harry. Yes, I remember you. Hello, Craig. Welcome, my friend. Hello. Yes, I remember you, Gaming Harry. I think I remember you. Hello. Yes, long time. I know, long time ago. It's been a minute, guys. Yeah, it's been a minute. Okay, but yeah, thank you for actually joining me tonight. Thank you for joining me on a Monday night. Yeah, during your Easter break. So collect like terms. We're gonna have minus 10 is equal to 8a plus 2a makes 10a. We got that plus 4b. Okay. I can now solve equations. Yeah, I've been good actually. Thank you. I've been good. Hello, Sarah. Welcome, Sarah. Yeah, I've been good actually, Gaming Harry. Yeah. How are you doing, my friend? Is everything okay on your end? So I'm going to solve these. So I'm going to do 1 minus 2. 13a minus 10a makes 3a. 4b minus 4b obviously goes to 0. And then 0 minus 10 goes to 0 plus 10. So 3a equals 10. So a is equal to 10 thirds. So a is equal to 10 thirds. Now what's b going to be? So let's sub it into equation 1. It's not much of a difference. We're going to have 13 lots of 10 thirds, so that's going to be 130 thirds. So we're going to have 130 thirds. Okay. Plus 4b is equal to 0. Okay. So I'm going to rearrange it. So I'm going to subtract 130 thirds, and then divide by 4. So we're going to have b is equal to minus 130 over 12. Okay. Which is what? So that's going to be minus 65 over 6. Is that right? Okay. Okay. And we'll leave it like that. Okay. So that's what B is. Okay, we know what A is. So our answer going to read, okay, so we've got 3a lots of x squared. So we have 3a, so 3 times 10 thirds. Well, that'll just go to, yeah, just 10. So we're going to have 10x squared. Okay, obviously, yeah, it's plus a will obviously equal to 10 thirds. This is an interesting problem, guys. It's an interesting problem. So, yes, yeah, so we're going to have 10 thirds x cubed. Well, why have I put that there? Sorry about that. Okay, sorry. That's the derivative. Sorry, yeah, sorry about that. Okay, there we go. So a is equal to 10 thirds. So we're going to have 10 thirds x cubed. We're going to have 10 thirds x at the end. So we're going to have 10 thirds x cubed. And then we're going to have 10 thirds x, okay, because the coefficient of x cubed is the same as coefficient of x squared here from line 1. Okay, and then b is going to equal to minus 65 6. Okay, obviously I solved it, yes, simultaneously. Okay, so we're going to have 10x cubed, okay, minus 65 6. X squared plus 10 thirds x. That, guys, is equal to g of x. Okay, so that was quite a chunky 7-mark question. Okay, right. What about part B? Prove that prove that stationary point 10 is a minimum. So I'm going to find the second derivative. Okay, so I'm going to find the first and second derivative. So the first derivative, yeah, is going to hopefully be nice and easy. Okay, hopefully it's not too much of like a fraction problem. So we're going to have 10 thirds times 3, so that would just go to 10. So we're going to have 10 squared. So 10x squared, then minus 65 6 times it by 2. So that's going to go to minus 65 thirds x. And then plus 10 thirds x. Going to go to obviously plus 10 thirds. Okay. And the second derivative, so that's going to be g dash of x. So g dash. Okay, and then g double dash. Okay, find the second derivative. Okay, so 10x squared is going to go to just 20x. Okay, and then 65 thirds x obviously go to just minus 65 thirds. I'm now going to substitute in x equals 2. Okay. Have I done this right? Yeah, let's double check. Yes. So when x is 2, we're going to have 20 times 2 is going to be 40. So 40 subtract 65 thirds. Hmm. 40 will be equal to 120 thirds. So 120 thirds subtract 65 thirds. Okay, that's going to be bigger than 0. Okay, so what are we going to get, guys? So to prove that it's a minimum point, guys, to prove that it's a minimum point, yeah, obviously bigger. Oh yeah, sorry, yeah, bigger than 0. Yeah, sorry about the bigger than 0. Therefore, it's a minimum point. Okay, yeah, sorry about that. Yeah, we got there in the end. Okay. Okay, does that make sense, guys? Well, then, okay, spot on here, yep, spot on. So I had like a lapse that I kept reading it as that maximum. So yeah, we go, okay, yep. So obviously it's bigger than 0, therefore it's a minimum point. Okay. Sorry, for some reason, like, I kept reading that word as maximum actually rather than minimum. Hence why I went a bit quiet. So if it's minimum, yeah, it's bigger than 0. If it's a maximum, I suppose, yeah, less than 0. Okay. Right. Let us try question 14. So, y is equal to 2x cubed plus 5x squared minus 7x plus 10. Okay, so find the equation of the tangent of the point x equals 1. Give your answer in the form y is equal to mx plus c. Okay, so again, step 1, I'm going to find the first derivative. So I'm going to write it, yeah, y dash k to y dash of x, the first derivative. Okay, 2x cubed will obviously go to 6x squared. Hello, Janelle, welcome. Hello, hello. Okay, so that's going to go to 6x squared. Okay, 5x squared will obviously go to an x. So this is actually AS.Maths, yeah, Janelle, sorry, yeah. So this is actually A level, yeah, pure maths. So no GC yet tonight, sorry, okay. Minus 7x obviously go to minus 7, and then plus 10 obviously obviously 0. Okay, so I'm going to sub in, yeah, x equals 1 into the first derivative. We're going to have 6 times 1 squared, so that's going to be 6 plus 10 minus 7. 6 plus 10 is equal to 16 minus 7 going to equal 9. Okay, so x equals 1, and obviously to work out what. So we got x equals 1, y is equal to 2 plus 5 is going to be 7 minus 7 makes 0 plus 10. So y is going to be equal to 10 when x is equal to 1. Is that right? Yeah. 2. Yeah. Hello, Saf. Welcome. So yeah, okay. Now I'm going to use y minus y1 equal to m brackets x minus x1. Okay. So we're going to have y minus 10 is equal to m, which is equal to 9, brackets x minus x1, so x minus 1, okay, because that's our x coordinate. Okay, I'm now going to expand this bracket out. Okay, so I'm going to have y minus 10 equal to 9x minus 9. I'm going to add 10 to both sides, so we get y is equal to 9x plus 1. Okay, we're happy with that, guys? Yeah, that makes sense. Are you happy with that? Any questions? Okay, I'll take that as a yes or a no, sorry. No one's got any more questions. Okay, let's move on then. Okay, so I think a lot of these, okay, so someone was asking for minimum, okay, sorry, not minimum, sorry, someone was asking me earlier for modeling with this, okay, so let's give this question a go, okay, question 17, okay, a simple model for the cost of a car journey in pounds C, so the cost of pounds, when a car is driven at a steady speed of V meters per hour, okay, is C is equal to 4,500 over V plus V plus 10. Hello, son, welcome. Okay, where, okay, yeah, so C is the cost of a car journey, okay, it's traveling at a speed. So use this model to find the value of V, which minimizes the cost, okay. So we're going to find, yeah, the first derivative, okay, and obviously, yeah, set it equal to 0. So we're going to have V, sorry, C is equal to, so C is equal to 4,500 V to the minus 1 plus V is equal to 10. Okay. So use this model to find the value of V, which minimizes the cost, okay? So looking for the minimum cost, okay, of a journey. Obviously, V can't obviously equal 0, okay? Yeah, so V can't equal 0, okay? For that, okay? So dC by dV is equal to minus 4,500, okay, V to the minus 2, then plus V, what, yeah, go to plus 1, and that plus 10 goes to 0, okay? So it says use this model to find the value of V, which minimizes the cost. So we want obviously the cost to be as small as possible, okay? So we're going to set the rate of change of the cost here with respect to the speed equal to 0, yeah, and obviously solve that, okay? So we're going to have minus 4,500, yeah, over V squared plus 1 is equal to 0. I'm going to flip this side here, just obviously make it easier. So I'm going to have plus there. That's obviously going to become minus 1 there equals 0. I'm going to add 1, okay? So I'm going to have 4,500 over V squared is equal to 1, okay? Reciprocate obviously both sides. So we're going to have V squared over 4,500 equal to 1. So V squared is equal to 4,500. Okay, so V is going to equal to plus or minus square root of that, or v equals, equals the square root of 4,500. If we bring that into our Casio, guys, our Casio calculator, okay, we're going to get 67.1 miles per hour to 1 decimal place. Okay, so that, guys, is our answer, okay? So does that make sense, guys? Oh, is it zoomed in? Oh, sorry, miss, sorry. Hello, it's Miss Smith. Welcome, miss. Hello, hope you're well. Yeah, sorry, miss. Yeah, I'm not sure how I've actually zoomed it in. But on the next slide, I'm going to try and obviously fix it. But yeah, thank you for liking, miss. Thank you for joining. Just doing some AS.Pure.Maths tonight, yeah, for my students. Okay, and for my followers actually on here tonight. So the value of V, which minimizes the cost, guys, is going to be 67.1, okay, miles per hour. Okay, remember, yeah, so check our units here. So mph, okay, and that, guys, is our final answer, okay? So whenever we are asking for like minimum cost or minimum points, guys, you always set the first derivative equal to 0 and then solve it, okay? So that's part A done, okay? Sorry, the handwriting is actually a bit scruffy here. Sorry about that, guys. Part A, you find dv by dc, set it equal to 0, and then solve the equation, okay? So you get 67.1 miles per hour, okay? And that, guys, is my final answer, okay? What about part B, guys? So use d2c by dv squared to verify that c is the minimum for the value of v. So find the second derivative, okay? So let's just obviously highlight the first part. So that's equal to our that's equal to our number. Okay, so again, dc by dv, okay, I've rubbed it off actually, sorry about that, guys. So dc by dv, okay, so the first derivative, okay, it's going to go to minus 5,000. Oh, 1 second, guys, sorry. 1 second, guys, sorry, 1 second. I need to go to my, let's just change the, oh no, I messed up, there we go, sorry, guys, okay, sorry about that. Okay, so, sorry, guys, I lost my train of thought there. So that's going to go to minus 4,500, v to the minus 2, okay? So the power comes down as a multiplier, the power goes down by 1, okay? Plus v will go to plus 1, then the derivative of 10, guys, is just equal to 0, okay? So that's the first derivative. Okay, what about the second one, guys? So d2c by dv squared, okay? So let's obviously work it out, okay, bit by bit, okay? So we're going to have a minus, and minus here makes a plus, so we're going to have 4,500, okay, v to the minus 2, and then plus 1. And now the question says verify that c is the minimum, okay, so that's when the second derivative, okay, is less than 0, okay? So I'm going to sub in v is, well done, Hayder King, yep, spot on, my friend, okay? So, well, I put a plus 1 there, sorry, ignore me, okay, sorry. There shouldn't be a plus 1 there, okay, thank you for that. There we go. Okay, so, we're going to sub in this into here, okay, so we're going to have 4,500, okay, multiplied by, okay, 67.1 to the minus 2. Now if we plug this into our calculator, okay, we're obviously going to get an answer here smaller than 0, okay, which is what we call a minimum point. And the reason for that is because obviously a negative power makes it 1 over. So this is the same as doing 4,500 over 67.1 squared. If you do that, you see the bottom here is going to be quite big, okay. So this is going to be less than 0, therefore we have a minimum point, okay. So that's our answer there, okay. Are we happy with that, guys? Yeah, does that make sense? Okay, well done, hey the king. Ooh. Okay, guys, right. Okay. That's part B done. Now that's to work out the minimum cost of the journey. Okay. So the minimum cost or minimum cost, okay, is obviously setting C to obviously equal to 0, okay, obviously as small as possible, okay, and getting our quadratic, okay. Oh, sorry, guys, sorry, it should be to the power of -3, sorry. What we're doing here, yeah. Sorry, it should be -2 there. Then it should be a power of -3, yeah, sorry about that, okay, so -3. So I'm going to have a cube there, okay. So yeah. Sorry, this is going to be equal to a number bigger than 0. Okay, that's what I meant. If we've got a local minimum. Okay, there we go. Okay, let's see. So, we're going to sub in answer from part E to work out what the minimum cost is. Okay, the speed is 67 miles per hour. So the cost is going to equal to 4,500 over 67.1. Okay, plus 67.1 plus 10. When we plug this into our calculator, guys, what we're going to get, we are going to get £144, okay, to the nearest whole number, okay? Okay. So yeah, okay, sorry about that, okay, yeah. So the first derivative, the first derivative should be minus 4,500 v to the -2, there we go, yeah, plus 1. And then the second derivative should be 4,500 v to the -3. Plug in this into our answer, into the second derivative, getting an answer, obviously bigger than 0, okay, so we've got a minimum point, okay, the negative power makes it 1 over, okay, so there we go, okay, so we got there in the end. Right. Yeah, no worries, Hello, Maths Fix. Welcome, my friend. Hello. Right. Let's have a look, guys. Let's have a look. I want us to try, like a challenging question, obviously, not too difficult. Okay, let us try, question 37. Okay, it's a bit more of like an interesting one. So 37. A curve has the equation y equals 8x plus 1 over 2x squared. Find an expression for over the x, okay? So let's work it out. So step 1, write it in what we call index form. How do I come out of this? There we go. So we're going to have y is equal to 8x plus a half x to the minus 2. Okay, is I can split 1 over 2x squared as a half times 1 over x squared. Now 1 over x squared can be written as x to the power minus 2. Okay, so let's work out the first derivative. So that's going to be 8 minus x to the minus 3, or minus 1x to the minus 3. Okay. What about part B? Find the expression for d2y by dx squared. Okay, so that's going to go to plus x to the minus 4. Okay, think of it, the 1 there. Okay, minus 1 times 3, minus 3, makes positive 1. And then not for the power. By I, okay, a bit more trickier. Hence, find the coordinates of the stationary points and determine its nature. So we're going to set the first derivative equal to 0, and obviously solve it. We're going to have 8 minus 1 over x cubed equal to 0. Okay, I'm going to add it to both sides. So we're going to have 1 over x cubed equal to 8. And reciprocate both sides. Okay, so flip both sides of the equation. It's going to go to x cubed is equal to an 8th. So x is equal to the cube root of an 8th. So x is equal to a half. Okay. Cube root of 1 is 1. The cube root of 8 is 2. So we have 1/2. Okay. What next? Well, got my x coordinate. I've got to obviously work out my y coordinate. Okay. X is a half. So we're going to have y is equal to lots of half. That's going to be 4. So we're going to have 4 plus 1 over 2 lots of a half squared. So that's going to be 2 times a quarter. That obviously become a half. So 1 over a half just obviously goes to 2. 4 plus 2 is 6. So the y coordinate when x equals a half is equal to 6. Hello T, welcome. Hello. Okay, so it's equal to 6. So now I'm going to work out this. I'm going to sub in x equals a half to the second derivative. So I'm going to have a half to the power of minus 4. Okay. Now remember, there's a negative power. It actually flips it. So it becomes 2 to the power of 4, which is equal to 16. Now that's bigger than 0. Therefore, half 6 the minimum point. Okay. So it's what we call local minima. Local minimum. Okay. If it's bigger than 0, it's a minimum. If it's greater than 0, it's a maximum. If it's equal to 0, then it's a point of inflection. Okay. Hello T, welcome. Hello. I hope you're well. So that's 37 actually done. Okay, let's try. I think my laptop is frozen a bit. I think it has. Am I able to go down or not? Okay, let's do 38. Okay, then we'll do a few intuition questions and then we'll call it a night. Okay, so let's do question 38. Show that the only stationary point on the graph y is equal to x squared minus 8 root x, the minimum point at 1, 6. So step 1, dy by dx. Okay, obviously write it in our form first. Okay, so 2x squared is going to go to just 4x. Minus 8 root x, that's going to be minus 8x to the power of a half. Okay, so that will obviously be a minus 4x to the power of minus half. Okay, set this equal to 0 and then obviously solve it. So I'm going to have 4x minus 4 over x to the half. Okay, is equal to 0. Okay, times up by x to the half. Okay, what we're going to get? We are going to get 4x to the power of 3 halves. Subtract 4 equal to 0. Divide everything here by 4. Okay, move it over here and then divide by 4. We're going to have x to the power of 3 halves equal to 1. So obviously x is going to equal to 1. Okay, so x equals 1. Okay, then y is going to be equal to 2 times 1 squared, so that's going to be 2 minus 8 root 1. That's going to be 2 minus 8. It's going to be minus 6. So y is equal to minus 6. Okay, that's the only solution. Okay, because we obviously had the equation 4x to the 3 halves. Subtract 4 is equal to 0. Okay, there's no other solution. Then x is equal to 1. Hello, Kate. Welcome. Hello, Bags. Welcome. Right, guys. We'll finish the demonstration, I think, for now. Okay. I think, on like another live, we'll do the other questions. Okay. Let's have a look at next topic. So let's have a look at some integration if we can. Just a few, I think. Okay. Okay, so yes, pure math. Okay, looking at some integration now. Okay, so we got y is equal to 2x cubed plus 5x squared minus 7x plus 10. Find the indefinite integral of y. Okay, yeah, so this is indefinite. Okay, so we're going to add 1 to the power and then divide by the new power. So we're going to have 2x to the 4 over 4. Okay, plus 5x cubed over 3, or 5/3 x cubed. Okay, minus 7x is equal to minus 7x squared over 2, or minus 7 halves, yeah, x, yeah, over 2, and then plus 10 is equal to just plus 10x. Hello, Spider, welcome. Hello, hello. Hello, Yusuf. It's 10x plus c. Okay. Let's just, yeah, obviously to just simplify, yeah, the first fraction. So that's going to be 1 over 2, or half x. So we're going to have a half x power of 4 plus 5/3 x cubed plus 7 halves x squared plus 10x plus c. Okay, don't forget, yeah, that constant of integration, the plus c. Okay, what about question 2? And the integral of 3x squared 7x minus 2. Okay, so that's going to go to 3x cubed over 3, so that's going to go to x cubed. Okay, yeah, 3 is cancel, yeah, if you're not sure, yeah, let's write it in. Okay, we're going to have 7x squared over 2. Minus 2, obviously go to minus 2x, or minus 2x to the 1. The 1 over 1. Obviously, yeah, that was c at the end. Hello, A, welcome. Hello, A, welcome, welcome. Okay, so this is obviously going to cancel, so I'm going to be left with just x cubed, 7 halves x squared, minus 2x, A plus c. That's our answer to question 2. What about question 3, guys? Find the indefinite integral of x plus 4 times x minus 3. So I'm obviously going to expand the brackets here. Okay, using FOIL, I have x squared minus 3x plus 4x, so that's going to go to plus x, or plus 1x. Okay, and then 4 times minus 3 is minus 12. Okay. Okay. So again, integrate in this key, we're going to add 1 to the power, then divide by the new power. So we're going to have x cubed over 3 plus x squared over 2 minus 12x. Okay. And then plus that c at the end. Okay. Plus c. Okay. So yeah, that's our indefinite integral. Okay. Do a few more, guys, yeah, and then I think I'll call it a night. Okay, yeah. I don't want to do too much, yeah, on the first session. Okay. So I'll come back to 4 actually in a minute, yeah. So let's do 5 first. Okay, so we got y is equal to 4 root x plus 1 over x squared plus 10. Okay, find the indefinite integral of y with respect to x. So step 1, write it in index form. So we're going to have y is equal to 4x to the power of a half. Then 1 over x squared will obviously go to x to the minus 2. So we're going to have plus x to the minus 2. Okay, plus that 10. Okay, so again, same process again. Okay, I'm going to obviously add 1 to the power and then divide by the new power. So I'm going to have 4x to the power of 3 halves over 3 halves. So I'm going to have 4 lots of 2/3. Okay, x to the 3 halves. Okay, is dividing by 3 halves, same as multiplying by the reciprocal. It's x minus 2, so that's going to go to minus x to the minus 1. Okay, and then 10 is going to go to plus 10x. Yeah, don't forget that c. So we're going to have 8/3 x to the power of 3 halves. Okay, subtract 1 over x, or x to the minus 1, plus 10x plus c. Okay, so we add 1 to the power and we divide by the new power. Okay, does that make sense, guys? Are we happy with that? Make sense? Okay, we'll just do one more. Okay, so let's do question 4. And I think, yeah, we'll call it a night, okay, because it's just getting, 8 in the evening now. It's nearly 9 o'clock. Okay, f dash of x equals 6x squared minus 3x plus 8. Given the point 1, 8 lies on the function y equals of x, find an expression for f of x. Okay, so step 1, I'm obviously going to integrate it, so I'm going to have the integral of this. So this is going to go to 6x cubed over 3 minus 3x squared over 2 plus 8x so plus 8x, and do not forget that constant of integration, the c. Okay, so we are got, obviously y is going to be equal to this, okay, or f of x is going to be equal to this. So obviously let y equal to this. Okay. So this is obviously going to simplify to y is equal to 2x cubed, because 6 over 3 makes 2. So we're going to have 2x cubed minus 3 halves x squared plus 8x plus c. So now I'm going to sub in x equals 1 and y equals 8 to work out what plus c is. So I'm going to have 8 is equal to 2 lots of 1. So that's 1 cubed. So that's going to be 2 minus 3 halves plus 8 plus c. Okay. So let's just obviously take 8 from both sides, and obviously take 2 from both sides. So we're going to have minus 2 equal to 3 halves plus c. Okay. So c is going to be equal to minus 7 halves, because minus 2 will be equal to, hello Miss Geography, welcome, hello. Welcome Miss, welcome. So because minus 2 is going to be equal to minus 7. sorry, minus 4 halves. So minus 4 halves minus 3 halves makes minus 7 halves. Okay. Okay, so our final answer just reads 2x cubed minus 3 halves x squared plus 8x minus 7 halves. Oh, no. There we go. Okay, sorry guys. So it's going to be minus 7 halves. That is an expression for f of x, okay, in the first derivative given a set of coordinates, okay. So we obviously integrate dash of x back to f of x, okay, because that's the opposite of the derivative of the differentiation, okay. So yeah, okay, so I think we'll call it a day, yeah, because it's just getting quite late in the evening. It's currently 9 o'clock now. Okay, I'm going to call it a night, okay, for today. And we'll carry on with more questions in our next live. Okay, hopefully the next one, yeah, we'll obviously go on YouTube directly. Okay, but anyone that's obviously missed it, okay, then you're able to, to obviously watch the re-upload, okay, in due course, okay, hopefully tomorrow or not the day after. Yeah, that is summarizing basic integration, basic differentiation, okay, in just, roughly over an hour, okay? So doing some practice questions and getting prepped, for our upcoming exam, for our end of year 12, end of year 13 exam, your AS and A.Pure.Maths exam, okay? So we'll call it a day, so thank you to everyone that has actually come tonight, okay? I shall see you, okay, very soon, okay? So thanks for being here, guys. Again, thank you for 6.1k. Thank you for anyone that gave like a diamond. Okay, I shall see you all inside the next stream. Okay, but for now, take care, all the best. Enjoy your evening. Okay? Happy Easter. Bye for now.